All right, perfect. Thank you. Hello everyone. Welcome to today's Drought in the Midwest webinar. My name is Molly Wolozin, and I coordinate the Midwest Drought Early Warning System at NOAA's NIDIS, or National Integrated Drought Information System. I'm located in Champaign, Illinois, and I'm with the Cooperative Institute for Research in Environmental Sciences at the University of Colorado. This webinar is part of a series of bi-monthly drought webinars designed to provide stakeholders and other interested parties in the Midwest with timely and relevant drought information and resources. First, just some housekeeping items. On this webinar, all attendees are muted. If you have questions during the webinar, please ask them using the Q&A feature on Zoom. If you don't see it as a selection on the bottom of your screen right away, you might have to select the More button, and then you should see a panel for Q&A. We will save our questions for the very end of the webinar after all three speakers. Finally, this webinar is being recorded. The webinar recording will be available on the NIDIS YouTube channel and linked from the webinars page on drought.gov/webinars. And we'll send an email when the webinar recording has been posted. So our agenda today will include three presentations. First, we'll hear about current drought conditions and impacts across the Midwest from Zach Leeser, who's the Missouri State climatologist at the University of Missouri. Next, Trent Frey, who's a meteorologist at the National Weather Service office in Detroit, Michigan, will give us an overview of the drought outlook. And finally, today's special presentation will be given by Kelsey Eichste, who is with Ceres and NIDIS like me, and she will provide an overview of some new findings for regional and seasonal relevance of drought indicators for the Midwest region. And then finally, we will end with a Q&A session. So first, I wanted to take a quick moment to highlight the partners that help make this webinar series possible. First, a special thank you to the Midwestern Regional Climate Center at Purdue for co-hosting today's webinar with me. The MRCC and other partners across the region are instrumental in the development of these webinars, and the products and services they provide are pivotal to staying updated on conditions across the region. Before we begin presentations, a brief background on NIDIS. NIDIS was created by Congress in 2006 with a mandate to help the nation prepare for, mitigate, and respond to the effects of drought. NIDIS does this through a series of activities, including the coordination of our regional drought early warning systems, or DEWs, shown on the map here, and through support to improve drought predictions and forecasting, effective drought planning and preparedness, and assessing the impacts of drought. All of NIDIS's work is done in collaboration with a wide range of partners at all levels. In addition, NIDIS hosts the U.S. Drought Portal available at drought.gov. The Drought Portal provides up-to-date drought conditions across a variety of scales, interactive and customizable maps, historical drought information, and a lot more. We encourage you to visit drought.gov for more drought information. So next, if you want to stay in touch with NIDIS and the Midwest DEWs, please use the link, which I will put in the chat box here in just a few minutes, to sign up for our national or regional newsletters. And a few more notes. To facilitate our early warning system, more precipitation observations are needed. We encourage you to join CocoRa's, the Community Collaborative Rain, Hail, and Snow Network. CocoRa's is a nonprofit community-based network of volunteers of all ages and backgrounds who work together to measure and map rain, hail, and snow, and to report conditions. To become a volunteer or to learn more, you can visit cocoras.org. And also, understanding on-the-ground impacts of drought is important for accurate drought monitoring and response. So one way to report your drought impacts is through the Condition Monitor Observer Reports, or CMOR system, hosted by the National Drought Mitigation Center. Another way for you to report is through the CocoRa's observation program by submitting a condition monitoring report. These are both great user-friendly systems to submit the impacts you are experiencing from too much or too little water. And becoming a regular reporter makes this information more accessible to those who assess drought in your state. And I will put all of these links in the chat box here in just a second. But without further ado, I will now pass it off to Zach Leeser, who is up for our first presentation. And just a reminder to please use the Q&A feature on Zoom in order to add any of your questions, and we will address those questions at the end. Zach?
Great, thank you, Molly, and hello, everyone. My name is Zach Leeser, and today I'm going to be talking about our current drought conditions and impacts across the Midwest. So just to start here, it's kind of unusual for a drought webinar to have a picture of frozen precipitation, but that's what we have here is Evansville, Indiana on January 25th, a look at part of the downtown area. Obviously a very heavy snow and impactful winter storm there. And then we see the Ohio River as well, which at the moment looked to not have any ice on it or very little, and a barge moving down that river as well. So I think with the time of year in February, droughts not always as visible, and actually today we'll have some snow and winter precipitation to consider there as well. So looking back to the past 90 days is where I want to start here is this on the left is the U.S. Drought Monitor for the Midwest U.S. On November 4th, 2025. So this is really how we ended the growing season across the region, and you can see quite a bit of dryness and drought across the entire region. So as of November 4th in 2025, the Midwest, at least 65% of the area was at least abnormally dry, but we also had moderate drought, severe drought, or D2 in nearly every state, and that red extreme drought, or D3, in Illinois, Indiana, and Northwest Ohio as well. So a pretty widespread drought to kind of end the growing season across the Midwest. And then if we look on the right, this is the percent of normal precipitation roughly over the past 90 days. And we can see a lot of red on this map. And so for most of the Midwest, we ended last year dry and have really just continued that here into 2026. And so nearly the entire southern half of the Midwest region here saw below average precipitation, a little bit more mixed to the north, but the only place that really we saw a wet signal with well above average precipitation would have been there in the upper peninsula of Michigan. And if we go forward now and look at the next slide for the most recent drought monitor map that was released today, you'll see the kind of coverage and severity of the drought look pretty similar here as well. So as of today, February 5th, we still have 60% of the Midwest that's at least abnormally dry. And of course, we do see that moderate and severe drought persisting. And that D3 is in the same locations in Northwest Ohio, Indiana, and Illinois, maybe even a little bit expansive in some of those locations, and has entered into the southern parts of Missouri as well. So if you look on the right, this is the change map going back to November 4th to today's drought monitor. And we do see some greens where there was improvement maybe along that northern edge of the drought last season in Missouri, northern Illinois, and Michigan. But where there have been improvements, we've also seen degradations, especially in the southern part of the Midwest, where we see those yellows and orange colors as well. And so part of the reason we see this drought is on the next slide, we'll look at December precipitation. And for a lot of the Midwest, we saw some wintry precipitation at the end of November, and then it was a remarkably dry December here. And so these are our December precipitation departures across the region. A few things I'll note here. Nearly the entire Midwest saw less precipitation than average, but obviously the drier locations you see on the map with those reds are in the southern Midwest. And so these were areas that received little to no significant precipitation, but also are locations that see less of a decline in winter precipitation than areas farther north in the Midwest. And I did put a few top 5 driest December long-term co-op sites here, and we see Joplin, Missouri, an impressive 0.04 inches. That was their record driest December. But then we also had a top 5 driest December in places like Carbondale, Illinois, and Paducah, Kentucky as well. Then on the next slide, if we look at 2026, that dry December has really continued as a dry start here for the year. And so these are the same precipitation departures from January 1st through the first couple days of February, and much of the same pattern. So except for parts of northern Michigan and Wisconsin here, most of us in the Midwest have been drier than average, and the largest departures from average have been in the southern part of the region here. But again, we see some record to near record monthly dryness for January as well. Parts of Minnesota, like Alexandria or Red Lake Falls, recorded little to no precipitation, but we also had the record driest January in Terre Haute, Indiana, with a close to record in Cincinnati, Ohio, and Zanesville as well. So seeing some of this near record dryness in many different locations. And so if we go to the next slide, we'll see how that precipitation has fallen. So the past few maps are really looking at our liquid precipitation, or if it was wintry frozen precipitation, what that would be after it was melted here. And that's important because if we look at the map on our left, it's been a snowy winter for a lot of us. So this is the season accumulated snowfall to date, valid through February 3rd here. And a lot of the region has had a lot of snowfall, especially over the past 30 days or so. And if we look on the right, this is the accumulated snowfall percent of average through this part of the season. And everywhere that's green or blue on this map is ahead of average for their snowfall so far. So most of us, with the exception of parts of the northern Midwest that get a lot more snow on average, are seeing a snowier than average winter up until this point. And of course, you can see some of the blues on that map for the percent average snowfall, showing the footprint of that most recent winter storm there, and putting some impressive totals across the region. If we look at the next slide, I think the big story really as far as drought in the past couple weeks has been our recent winter storm. So on the left is the daily snow depth or snowpack. This was Monday morning, January 26th, when this map would be valid here. And this was pretty much at the end of the storm when we had our highest snow totals here. And you can see across the southern half of the Midwest, a really impressive band there of the highest snow totals. Now, on the right shows the same map, but our snow depth on the morning of February 3rd. And you'll see some melting, but also that there's still quite a bit of snow on the ground there. So we've seen some additional melting as well over the past couple days, but the big story has been that snow has sat on the ground for quite some time. In some locations might have been low water equivalent. And we want to know, from a drought perspective, how much of that melting snow can make it into the soil or infiltrate as water or recharge our surface water as well. So the next slide will show an important component there, and I think maybe beneficial from drought recovery here are the soil temperatures. And so this map is the 4-inch soil temperature underside, and what we see is a lot of dark blue in the southern part of the region. Farther north, we know our soils are frozen, in many cases very deep as well. But to the south, we don't see that throughout the entire winter. And in fact, that dark blue shows 30 to 35 degrees, and we have soil temperatures that are right around or above freezing. So in some locations, this will allow us that snow melts to infiltrate nicely into the soil. So this is good to see. I think it's one benefit of having that snowpack is it insulated the soils from some of those very cold temperatures we saw. And the next slide is why we're so concerned about infiltration of moisture into soils. And that's because one impact we've seen from this drought over the winter is drier than average soil moisture. And so again, this time of year, we don't think about as soil moisture as much with not vegetation growing, but for this time of year, our soil moisture is lower than average across most of these areas that are in drought. And so these are two soil moisture models. And one on the left is the North American Land Data Assimilation System. On the right is from the Climate Prediction Center. They're both in pretty good agreement, both with the drought coverage area, and where kind of drought is defined by the lower soil moisture percentiles on this map, but they're also in pretty good agreement with our severity too. So you can see both models show soil moisture percentiles below the 10th, which would be a D2 threshold, and below the 5th percentile, which would be a D3 severity as well. So these kind of support the current higher end severities that we see on the US Drought Monitor as well. And on the next slide, just want to show from the Climate Prediction Center model the kind of trend in soil moisture anomalies we've seen. So this goes back to November 30th and the soil moisture change from then until February 3rd. And really that southern part of the Midwest, we see a decline in soil moisture relative to average. So dry soils and heading in the wrong direction in some locations from a drought perspective. On the next slide, we'll see stream flow. And really, this shows kind of as an indicator a similar response to the precipitation deficits and drought. And that means that for the southern Midwest, you see on the map on the left a lot of watersheds that are colored orange or red, showing below normal to much below normal stream flow in those areas. And we even have across several states in the Midwest some of those bright reds, which show the lowest stream flow for that watershed over the past 7-day period. So some really widespread impacts here with reduced stream flow. Farther north in the Midwest, of course, we have to deal with some of these streams and rivers being frozen, so not as much of a clear signal with response to drought conditions. And it's not just some of these smaller watersheds that we see highlighted on the map. But our large rivers are also running low in response to this regional drought, but also water coming from outside of the Midwest too. So on the right here are a couple of river stage hydrographs for on top is the Ohio River at Cairo, and on bottom is the Missouri River at Herman. And then we see the climatology of those rivers in comparison to the red line, which is 2026 so far. So both large rivers we see are running below average for this time of year. The Ohio River, it's not record-breaking low, but is pretty low, but is responding to some of the more recent precipitation events with an increase in stage. But the Missouri River at Herman is even more dry. So you see that red line is out of the period of record, and we've been setting daily low water records there for almost a couple weeks. And as of today, that gauge is really just 1 foot above the all-time low water mark at the Missouri River at Herman. So very low stream flow on some of the larger rivers. And then to end here, just some other impacts and kind of a summary of the drought conditions. I think it's been the southern Midwest where we're seeing these wintertime impacts, especially in Missouri, Illinois, and Indiana. And also some states, either the lack of drought or the wintertime season means no noted impact or drought issues there. Things we are looking for where there's drought, seeing low soil moisture, and the cold temperatures have made things tricky as well, and trying to determine how effective soil moisture recharge was after the winter storm. In addition to low soil moisture, we're seeing a lot of low to much below stream flow there as well. And then some other more specific impacts. We haven't talked as much about up near the Great Lakes, but we know in northern Indiana and Ohio it's been dry. Lakes Michigan and Huron fell 4 inches from November to December, which was a larger than usual seasonal decline. And then in places like Sullivan and Bloomington, Illinois, there's even some voluntary water conservation in those areas due to low well and reservoir levels. That's something similar to what we're seeing here in Missouri. We have lots of dry ponds across the state, watching water table levels like Illinois. And even during our winter months, we have seen some wildfires across Mark Twain Forest in those drought areas. This one here would have been a 700-acre burn there, and even some dust, which is out of season as well. So I'll end here with this picture, another winter picture from the Drought Mitigation Center's Seymour reports. And this is from Dade County, Missouri, and I think describes the state of agricultural drought right now, where the picture shows looking out at a field with snow and thinking about how much of that water can eventually melt and get into the soil. So with that, I'll go ahead and end here. Here's my contact information on the next slide. And Molly and Trent, I'll turn it over to you all.
All right. Thank you so much, Zach. That was really great to give us a picture of what's going on across the region. So Trent, I will turn it over to you next to talk with us about the outlook information.
All right, thank you, Molly. Uh, my name is Trent Frey. Good afternoon, everybody, and I'm a forecaster at the National Weather Service Forecast Office in Detroit, and I'm going to be covering forecast and outlook information from the Weather Service. So go ahead to the next slide, please. So looking at the 7-day precipitation forecast, this is issued by the Weather Prediction Center of the National Weather Service. Key points here are for the Midwest that the Weather Service is forecasting generally light precipitation over the next 7 days. There will be a series of clipper systems that track through the Great Lakes, bringing intervals of light snow. The first is moving through today, then we have another one expected tomorrow, and then that will be followed by some lake effect snow through the weekend as colder Arctic air works back into the area. Through all these systems, generally about 1 to 4 inches of snow can be expected, with higher amounts possible in the usual lake effect belts. And with all of that, the melted liquid equivalent totals from these systems is forecast to range between about 1/10 of an inch to about 1/2 of an inch. And then getting into next week, there is growing confidence for, oh, sorry, you can go back. Thank you. There's growing confidence for a frontal low pressure system to develop across further south portions of the Midwest Tuesday through Thursday of next week. Right now, models generally want to place the frontal boundary along the mid-Mississippi into the Ohio Valley, which would serve as a focus for potential few rounds of precipitation. The forecast as of yesterday afternoon shown here generally held amounts around and below 1/2 inch. But there would be the potential for higher amounts than what's currently shown here for any areas that do see multiple rounds of showers. So there's still room for some forecast adjustment as we get closer in terms of amounts and placement of those higher amounts. But this system would bear watching as we get closer. As we get into the next slide, I have the outlook for the 8 to 14 day temperatures. And what we're looking at here are warmer than normal conditions being likely across the region for the week 2 period, with about 50 to 80% likelihood in the latest outlook by the Climate Prediction Center. The highest probabilities and highest confidence is across the southern states, getting into southern Missouri and Illinois, as well as western Kentucky. This relative warm-up is going to be driven by a deep upper trough over the western continental United States that will cause a ridge to develop downstream over the central and eastern part of the country. And this pattern shift would favor increasing temperatures late next week. There is, however, some uncertainty how strong this ridge will be and how long it'll set up and persist into next weekend. But it does look to redevelop the following week. So that gives us enough confidence to go with likely category here for above normal temperatures. So next slide, please. We'll get into the 8 to 14 day or the week 2 precipitation outlook. And probabilities during this period lean toward above normal precipitation for the week 2 period, with the highest probabilities targeting southern portions of the area near the lower Ohio Valley, where confidence is about 50 to 60% for above normal precip. During this period, as that ridge sets up in the east with that trough in the west, this would favor a storm track to set up somewhere across the center of the country, with some opportunity for occasional bouts of some Gulf moisture to be transported northward. So this would point to a good chance for several rounds of precip across the area, with the focus in the Ohio Valley, as the probabilities show there. Again, there's lower confidence as we get later into the period, as there's some uncertainty how that upper ridge progresses next weekend. But overall, this is what the precipitation outlook favors. And I will note that the CPC rated their forecast confidence for this week 2 period as a 3 out of 5. So just around average confidence here. As we get into the next slide, I can go over the 8 to 14 day hazards outlook that's in effect. And what this product shows is when confidence is high enough for CPC to outline specific hazards within the week 2 period, they'll do so in this hazards outlook here. And for this period, there is a slight risk of heavy precipitation over the Ohio Valley, vicinity between February 12th and 15th, with this being driven by model ensemble guidance, highlighting this area with elevated chances for over an inch of rainfall in this window. And this would come from potential for multiple rounds of precipitation along that stalled frontal boundary. And the next outlook for the week 2 period will be coming out later this afternoon. And then as we get into the week 3 to 4 temperature outlook here, getting into kind of the last half of the month here, model guidance generally favors another trough developing over the eastern United States, which favors a tilt back towards below normal temperatures for much of the Midwest. These probabilities are generally 33 to 40% for most of the area, but eastern portions of Ohio are slightly higher, at about 40 to 50%. Confidence is lower on a cool down across southern and western areas. So much of Missouri is given equal chances for above, near, or below normal temperatures during this period. Some added context here. There is potential for the stratospheric polar vortex to warm and weaken through the middle of February. And what this means is there's potential for it to split, which would potentially open the door for some more cold outbreaks across the Midwest through the end of the month and potentially beyond. So model and ensemble guidance currently show that there's some potential for this, but it's not quite high confidence yet, and still too soon to tell if there's going to be any changes to the stratosphere that will affect the surface. Just something that's being monitored behind the scenes and could potentially cause some changes to these outlooks. Next slide, please. As we look at the precipitation outlook for the last half of February, Kentucky looks like the main target for probabilities toward above normal precip. This is due to the troughing influence that is expected to develop over the eastern U.S. However, the rest of the area has equal chances for above, near, and below normal precipitation. And the next update to these week 3 to 4 outlooks will be issued tomorrow afternoon. And then next slide, we'll get into the seasonal temperature outlook. And this seasonal outlook looks at trends on the 3-month time scale. So in this case, we're looking at the outlook for February, March, and April coming up here. So the main thing that we're looking at here is that La Nina is ongoing, but that is expected to transition to ENSO neutral, which means that neither La Nina or El Nino will be going on. And even though we're transitioning away from La Nina still carries the most predictable signal for outlooks on this seasonal time scale. So the outlooks do carry and utilize some of this predictability that we do have. So the temperature outlook carries the look that's pretty standard for La Nina, with warm conditions in the south and cool conditions in the north. For the Midwest vicinity, the lean towards above normal conditions includes much of Kentucky, and then northern Minnesota has a lean toward below normal temperatures. And then equal chances elsewhere, which just means that there's no strong signal pointing in any direction as far as temperatures go. But like I did mention, the stratospheric polar vortex is something that's being watched. So if that weakens, that could potentially open the door for some Arctic air outbreaks, especially early in the season. Next slide, please. As we get into the precipitation outlook, this is also pretty characteristic of a La Nina setup, where we have above normal precipitation favored in the Ohio Valley and Great Lakes. This is a common impact of La Nina, especially during the late winter months. What's a little bit less common with La Nina is the extension of the higher probabilities into the upper Mississippi Valley. And this is tied to some of the seasonal forecast tools that CPC uses that are indicating higher probabilities up there. And then we have equal chances for above, near, or below normal for the rest of the Midwest. And all this kind of culminates in our seasonal drought outlook, which has much of the area in area of drought improvement or removal for much of the Midwest. This is because we're leaning toward above normal precip for much of the area in that seasonal outlook. So this includes some improvement in those extreme drought areas that Zach noted in Ohio, Indiana, and Illinois. It's not a guarantee by any means, but the outlooks do favor that there would be some improvement and some removal in that area. There is some lower confidence in above normal precip for western portions of the Midwest. So areas that are included in where drought would be favored to persist would be north central and northeast Minnesota, northwest Wisconsin, and southwestern Missouri. Those areas are just a little bit less likely to see those higher precipitation amounts. So the drought is favored to persist there. And then I'll wrap up with a quick summary here. We do have a few clippers moving through the Great Lakes this weekend into early next week with light snow. And then we're looking at a frontal system to bring potential for a couple rounds of precip to the mid-Mississippi and Ohio valleys next week, which could start to see some improvement with the drought conditions there if that does set up. And then a pattern shift would favor higher likelihood of warmer and wetter conditions late next week into the following week, so in that week 2 timeframe. And then as we get into the later part of the month, probabilities hint at the return of cooler weather to end the month for much of the area. The seasonal forecast leans towards above normal precip through April, so drought improvement or removal is likely for much of the Midwest, but there is the potential for drought persistence, and that would be favored in parts of Missouri, Minnesota, and Wisconsin, where there's just lower confidence on weather conditions during that period. And that's what I had for today. So thank you.
All right. Thank you so much. That was a great overview of the Outlook information. And thank you again to both you and Zach for that recap of conditions. So we are going to transition to our last presentation, which is a little bit of a different focus here, where we are moving on to talk about drought indicators for the region, specifically focusing on a project that NIDIS partnered with NASA on, and Kelsey from our team is going to present about that. So Kelsey, I will turn it over to you.
Thanks, Molly. So I'm Kelsey Eichste, and I'm going to talk today to share the results of a NASA-led research study that NIDIS partnered with NASA on and helped support, focused on analyzing the relative importance of different drought indicators by region and season, including for the Midwest. Next slide, please. So first, I want to give a little context on the motivation for this research, and then I'll provide an overview of the research and some of the key findings nationally and also for the Midwest region. The reason that NIDIS partnered with NASA on this study is because monitoring drought is complex and often involves tracking multiple indicators of drought conditions like precipitation or soil moisture. But which indicators are most important or relevant for monitoring drought depends on your location, your climate and geography, historical drought impacts that you've felt, and the time of the year. So improving our understanding of relevant drought indicators for specific regions at specific times of year can support more effective drought planning, decision-making, and communications. And that was a large part of the motivation for supporting this study. Next slide, please. So in response to this need to better understand drought indicators by region, NIDIS supported a team of scientists at NASA's Goddard Space Flight Center to quantify the relative importance, or what we're calling drought explainability, of 113 different drought indicators by location and season. The research is published in the Journal of Hydrometeorology, and you can scan the QR code on the slide here to view that publication. The research team used a mutual information, which is an information theory approach, to compare these 113 indicators to the U.S. Drought Monitor from 2006 to 2019. They then took this mutual information and normalized it so that you could compare the values across different geographic regions. There's a lot more information about their methodology in the publication, but at a high level, the mutual information is essentially the degree to which one data stream explains another stream, or the degree of common information between those two pieces of data. So when you're looking at a particular indicator, like 3-month standardized precipitation index, for example, that mutual information is the amount of information obtained about the U.S. Drought Monitor by observing that particular indicator. Or put another way, it's the extent to which that given indicator explains the drought monitor's depiction of drought. So the researchers looked at 113 different indicators across different timescales, including in situ modeled and remote sensing data. And they looked at how these indicators correlate with the U.S. Drought Monitor's depictions of drought from 2006 to 2019. And they did this at these geographic regions that you see on the map. at the side of the slide here. These regions are fairly large, and they roughly correspond to NOAA's Regional Climate Center regions. And they broke this down annually as well as by season for each of these regions of the continental United States. These are the 113 indicators that were included in the study, included observation-based, model-based, and remotely sensed indicators spanning precipitation, temperature, soil moisture, measures of evapotranspiration, runoff, stream flow, vegetation stress, and more, including several different combined drought indices that combine multiple indicators, the Standardized Precipitation Index, Standardized Precipitation Evapotranspiration Index, and the Palmer Drought Indices. I do want to note a couple of things about this list of indicators. One is that it includes multiple timescales for a number of the indicators like precipitation, SPI, SPEI, ranging from 1 month to 72 months. The study did not include sub 1 monthly timescales. So there's no 1 week precipitation, 7-day precipitation, 15-day precipitation included in the study. It also doesn't include things like reservoir data, for example. So there are a number of indicators that were not initially included in the study. So that's helpful to keep in mind as you are interpreting the results. A couple other quick caveats on this research before I give an overview of what we can learn from this research and the key findings of it. As I mentioned, this research uses the U.S. Drought Monitor from 2006 to 2019 as the training target or the truth of drought conditions. So it's comparing each of these indicators to the U.S. Drought Monitor's depiction of drought over that time period. Some caveats as a result of that. The U.S. Drought Monitor is obviously created by a rotating set of authors. They use a convergence of evidence approach. So that includes objective drought indicators like those that are analyzed in the study, but also subjective assessment based on expertise and local input. It's also important to note that not every indicator used by the Drought Monitor authors was included in the study, and that the indicators that the Drought Monitor authors rely on have changed over time, for example, as new data sets have become available. And of course, if we were to conduct a similar study using a different training target or a different truth of drought or a different time range, that may produce different fractional information values or different drought explainability, just like with any other technique. The bottom line is that the study can't tell us which data sets the Drought Monitor authors used, but it can tell us which data sets correlate with the U.S. Drought Monitor based on this analysis. It also can't tell us what indicators are most relevant for the current drought or a specific individual drought event, because different droughts can be driven by different factors. So this is looking across the U.S. Drought Monitor from 2006 to 2019 for the Midwest. Next slide, please. So the overall takeaways from this research, I want to give a high-level overview of some big findings that apply across the contiguous United States, and then I'll dive into the Midwest-specific results. The results of this research show which drought indicators from that list of 113 indicators are most representative of the U.S. Drought Monitor's depiction of drought for a given region and season. One of the big takeaways is that no individual indicator can define drought on its own, and there are seasonal differences, and that higher drought explainability comes when combining multiple indicators. When the researchers did this analysis, even the indicators with the highest fractional information or drought explainability still only had about 40% drought explainability for the U.S. Drought Monitor, and some that ranked highly had even less than that. The researchers in the study not only looked at how well individual indicators correspond to the U.S. Drought Monitor, but how different groupings of indicators combined correspond to the U.S. Drought Monitor's depiction of drought. And they found when looking at groupings of indicators, you got a greater total drought explainability. So the takeaway is that, looking at a curated suite of indicators is going to give you a better depiction, a more holistic depiction of drought. Another takeaway, the researchers looked as one of those groupings that I mentioned at the top 15 indicators, meaning the 15 indicators with the highest drought explainability for different regions and seasons. And when they looked at just the top 15 indicators combined, that had almost as much drought explainability for the US Drought Monitor as looking at all 113 indicators combined. So if you're looking at the top 15 from this study, that could capture about 55 to 75% of the explainability of the US Drought Monitor. That range kind of depends on which region or season you're looking at from these results. The takeaway is that there's a possibility that for some locations and seasons, a judicious selection of indicators could enable effective drought monitoring and forecasting. It may not be necessary to look at all 113. The final two takeaways that I want to mention at a high level are that the researchers also looked at all of the remote sensing indicators and all of the model-based indicators combined and compared the combined drought explainability or fractional information of these results to the US Drought Monitor to all 113 indicators combined. Remotely sensed and modeled indicators showed pretty high drought explainability, almost as much as all 113 indicators taken together, which suggests that this could be very useful for drought monitoring, which would be especially valuable in locations that are data scarce for in situ data. Now that I've provided that general context, I want to dive into some of the key takeaways for the Midwest region specifically. And before I dive in, I'll note that this research doesn't tell us why any of these indicators emerge as having high drought explainability with the US Drought Monitor, but I'll make some comments throughout on why a lot of them may make sense, and I'll highlight an additional study that provides some additional context for why some of these indicators may be emerging as highly relevant for the Midwest. So on the screen here, you can see the top 15 indicators with the highest drought explainability for the Midwest based on this study. And this is looking at all season data, so taking across the entire year across all seasons. One of the big takeaways from this is that soil moisture at a variety of different depths consistently emerged as a highly relevant indicator for the Midwest, both in the all-season analysis and for every individual season. Precipitation also emerged as a top indicator for drought, which makes a lot of sense. We had both a standardized precipitation index and precipitation show up at 2-month and 3-month timescales, emerging as highly relevant for the all-season data. We also see that the standardized precipitation evapotranspiration index, or SPEI, is relevant in the Midwest, especially at the 3-month timescale when we're looking at all seasons combined. The shorter timescales make a lot of sense for the Midwest. There's a lot of drought events in recent decades that have had drier stretches during the summer months. In the summer, the Midwest can get very hot. Even if you've had a wetter spring or winter, if summer precipitation is below normal or non-existent, drought can intensify very quickly. We've seen a lot of flash drought becoming more common in the region in recent decades. So these shorter time scales and the presence of evaporation-based indicators make a lot of sense. The Palmer Modified Drought Index, which is a modified version of the original Palmer Drought Severity Index, also emerges as a top indicator across all seasons. When we look at the seasonal breakdown for the Midwest, there's a few key themes that emerge. The first is that the timescales of importance range across seasons for precipitation indicators and SPEI. So in the winter and the spring, you see longer timescales at like 9-12 months emerge as highly relevant for precipitation SPI and SPEI, whereas you see more 3 to 6 month 2-3-6-month timescales emerge in the summer and fall for precipitation and SPEI. This makes sense with drought in the summer and fall can often be driven by a lack of precipitation in combination with hot temperatures, which can tend to be faster developing, and shorter timescales may emerge as more relevant in these seasons. In the winter, drought may not improve as rapidly because the ground is more frozen, especially in the northern regions of the Midwest. It's also one of the more dry times of the year for the Midwest. So if we have drought in the winter, it'd make sense to monitor using longer timescales. A couple other themes across the seasonal data: soil moisture emerges as a top indicator in every single season, as well as the all-season data. Runoff also emerges as a top indicator in almost every season except for summer, and especially relevant in the winter months. Groundwater also emerges as a top indicator, a highly relevant indicator in the winter. And then the Palmer Hydrological Drought Index and Palmer Modified Drought Index also show up among the indicators with the highest drought explainability in the spring and winter. So I'll just briefly go through each season and highlight a couple of takeaways of these data. The findings for the summer are really similar to what we see in the all-season results. This correlation may exist because drought tends to be more common in the summer months in the Midwest. Soil moisture and shorter-term indicators for precipitation and SPI emerge as top indicators, as does 2-month, 3-month, and 6-month SPEI. When we transition to the fall, similar indicators emerge as are relevant in the summer, but with the addition of runoff as an indicator with high relevance. This makes sense as we move out of the growing season. The Midwest may see those hydrological indicators pop up as more important if there is drought persisting into the fall. In the winter, I want to note the addition of groundwater in the results here. We see hydrological indicators emerge, groundwater, as well as the Palmer Hydrological Drought Index. This is the only season where we see groundwater emerge among this top list of highly relevant indicators for the Midwest region. And if drought persists into the winter, the Midwest may be looking at other types of drought beyond just agricultural drought. And it makes sense that we see some longer time scales relative to the other months of precipitation, SPI, SPEI at 6, 9, and 12-month timescales showing up as relevant. And then finally, looking at the spring data from March to May, as with the other seasons, soil moisture is consistently a prominent indicator. The drought in the spring in the Midwest also correlates with hydrological drought indicators like runoff and the Palmer Hydrologic Drought Index. Coming out of winter, where drought may not change very much, if there's drought in the spring, it could be the result of longer-term drought, so the hydrology may be showing impacts. And again, I'll highlight some longer timescales at 6 to 9 months for the precipitation-based indicators in the spring. So this is just one study looking at quantifying the relative importance of drought indicators in the Midwest, but there are other studies that have looked at similar questions and looking at drought indicator importance in the region. Looking at multiple studies, relying on local expertise, can provide helpful context for interpreting these results in the context of other research that has been done. So I want to give just one example of another study that looked at different indicators in the Midwest region. There's a study is led by Hoyle et al. It was published in the Journal of Hydrometeorology in 2021, and it looked at characteristics and predictability of drought in the Midwest from 1916 to 2015. And what this study did is it looked at a monthly integrated drought index, which took into account soil moisture, snow water equivalent, and 3-month runoff from land service models during this time range of 1916 to 2015. And you can see a map of the Midwest, several maps of the Midwest on this slide. And what this is showing is the correlation of that integrated drought index to snow water equivalent on the top row, to soil moisture in the middle row, and runoff on the bottom row. And darker blue values indicate a higher correlation with the integrated drought index. So that means when the integrated drought index is positive, there are more positive values for soil moisture. In drought conditions, the integrated drought index would be negative, and you would also expect to see more negative soil moisture values. And the study concluded that soil moisture and runoff overwhelmingly drive drought during all seasons based on the integrated drought index that they used in their study. So this really correlates well with some of the prominence of runoff and soil moisture that we're seeing in the results from this NASA study. Next slide. The study also looked at precipitation and temperature correlated to this integrated drought index. And they did show a strong positive correlation between drought and precipitation too, which I don't think will surprise anyone. They did found that temperature in their integrated drought index had a statistically significant correlation in the summer months, which they attributed to rapid drought development when above average temperatures can increase atmospheric evaporative demand and contribute to this rapid drying of the landscape and flash drought. But precip was shown to have a high correlation across all seasons, which we also see reflected in the results from this NASA study. So to wrap up, I want to just tell you a little bit about what we're doing next with the results of this NASA-led research. NIDIS has been partnering with NASA to communicate the results of this research and help translate those results into formats that make them easier to communicate and use. So over the last year, we have conducted several listening sessions. We've did a webinar for the National Weather Service staff to share the results. And we've worked to translate the research into an interactive and plain language format on drought.gov, developing a prototype web page that displays the research findings in an interactive way. And on the next couple slides, I'll show you some examples of what we have done to try to communicate this research effectively to make it more useful. So you can see here on the left, this is an example of one of the graphs from the original publication in the Journal of Hydrometeorology, showing the fractional information, which is on a scale of 0 to 1 for the top 15 indicators in the Midwest. And as you can see, I mentioned earlier that no one indicator has super high drought explainability. For the US Drought Monitor alone, you can see even the highest soil moisture indicators here are only a little bit above 0.3 fractional information or 30% drought explainability with the Drought Monitor. So if we add the next bit of this slide, this is what we have translated that into on drought.gov. We've tried to provide some high-level takeaways for each region, used icons and headings and stylings to make it easier to see which categories of indicators had higher drought explainability according to the study, and also to make it easier to see across seasons and across all seasons what timescales emerged as highly relevant. And this webpage is not live yet, but we are very close to releasing it and excited to share it very soon. We've also created an interactive table to more easily allow users to view the results of this research by region and season. So I dove into the Midwest results today, but all the other regions that are represented on the map that you can see, you can select a region, select a season, and easily see which indicators and timescales had higher fractional information for that region and season, as well as a link to the underlying data sets in the study and additional data sets that may not have been included in the study, but are still useful for drought monitoring of these different indicators. This is one example of how we're trying to make the data more interactive and easy to use and to communicate to others. Our next steps are to continue to explore ways to produce this information at a finer scale, like at a state level. We know that these results are at a very broad regional scale and that more research is needed, looking at different methodologies, different spatial scales, different training targets. So we welcome feedback on approaches on what would be most useful. And there's a QR code on the screen where you can sign up for our newsletters. We have a national newsletter as well as regional newsletters. And this is where you can sign up to hear when we do release these web pages that translate the findings of this research with the interactive data table, as well as other drought news and drought research and regional drought updates for the Midwest. Thank you so much.
Great. Thank you so much, Kelsey. And we will wrap up here with a few minutes for questions if anybody has them. So just a reminder to please type your questions into the chat box. But I did want to mention our next webinar will be on Thursday, April 2nd. We have them every other month. And so, obviously we do still have some drought issues across the region. that, we're still experiencing impacts throughout the winter. Maybe by the early April webinar, we will have a better picture on how this snowfall has potentially benefited the overall system, or, really be able to see what areas might still have issues as we're going into the growing season. So the next webinar should hopefully provide us a decent amount of information where maybe we will be going for the next few months. The contact information for our speakers are on the screen here. And I also put the link to sign up for the NIDIS newsletters if you want to keep in the loop on future communications about the research that Kelsey provided. Let's see. I don't think we have any questions right now, just a few comments, but if there's no other questions, then we can go ahead and wrap up just a couple of minutes early. Again, thank you all so much for attending, and a big thank you to our speakers for presenting today. And we will send out the recording by email to everybody who registered. So thank you again, and that concludes today's webinar.